Okay, so we've got a question here. We need to find the fixed points of a complex function, and then we're going to find out the characteristics of those points when we've found them. And the functions we're going to try and find are these four here. So let's get straight into the first one and see where we go. So we've got f of z equals z over 3 minus 2. Okay, so first things we need to find is the fixed point equation. And then what we're going to do is we're going to try and solve it for our variable, and then that will give us our fixed point. So the fixed point equation is f of alpha equals alpha. So that will then give us an equation which hopefully we can solve. So let's get straight into this one. So obviously we're not going to be using alpha, that's just for the demonstration of the formula. So here our variable is z. So obviously we have f of z equals z for our equation here. So here we'll then have z equals z over 3 minus 2. Okay, so now we do some algebra here and then we can solve this, that's for sure. So z minus z over 3 equals minus 2. So now z minus a third of z just gives us 2/3 of z. That equals minus 2. Multiply both sides by 3. 2z equals minus 6. Now divide both sides by 2 and we get z equals minus 3. Okay, so that's our first fixed point. So I'm going to find all the fixed points of these equations, and then I'm then going to find the character of each one at the end. Okay, so that's the first one. Second one, f of z equals z squared minus 4. So let's just write that up here. Z squared minus 4. So now using the fixed point equation, z equals z squared minus 4. Now we can see what's happening here. We've got a quadratic going to form up in a minute. So 0 equals z squared minus z minus 4. So you can see how we got that. We just subtract z from each side. Now we can try and solve this. Now z squared minus z minus 4, I don't know how to factor that, so I'm just going to use a quadratic formula and go straight in with that. So then if I use that, I'm going to have minus b, so I'm going to put my coefficients in here first. So minus b, so that's minus minus 1, that's going to give me 1, plus or minus square root. B squared, so that's going to give me a 1, minus 1 squared is 1, and then minus 4 times a times c, so 4 times 1 is 4, times minus 4 is minus 16. And then divide that by 2 times a, that's 2. So now I'm going to get two values for my z. So that would entail that this one has two fixed points for this equation. So now we're going to need to evaluate the character of 2 points at the end. So z equals 1 plus or minus square root 1 minus minus 16 is 17, and then divided by 2. So obviously we've got a plus root 17 and 1 minus root 17 on our numerator there. So let's write those in. 1 plus or minus square root of 17 all over 2. Okay, let's move on to this one. Clear the board. Okay, so now f of z equals z squared plus 4. So with all the experience we've had of solving quadratics over the years, we know this one is probably going to yield a complex solution. So as z is a complex number, that's not going to be a problem because that's what we're dealing with anyway. So straight into this characteristic equation, z equals z squared plus 4, subtract z from each side. So then we get z squared minus z plus 4. Okay, as we did before, straight into the quadratic formula, 1 minus 1 and plus 4. So then that's going to yield z equals minus b, so it's still a 1 in front, as we had here. 2a is going to still yield a 2. And then we're going to get plus or minus square root b squared, that's still 1. This time 4ac will be a positive number, so 4 times 1 times 4 is going to be 16. So there we're going to have a negative in our square root as predicted. So now z equals 1 plus or minus. Now square root of 1 minus 16, that's square root of minus 15. Square root of 15 in surds. I can't really simplify that up very much, so I'm just going to leave it as it is. And then that's all still divided by 2. So that's then going to give me my 2 solutions. So again, there's going to be 2 fixed points characteristics to solve for this equation. So z equals 1 plus or minus I root 15 over 2. Okay, this one here looks a little bit intimidating because we're going to have to try and solve a quartic by the looks of it. So z to the 4, that's a quartic. So let's see what happens. So f of z equals z to the 4 plus 4z squared plus z plus 4. Okay, we're going to need a bit of luck in solving this one. Hopefully it's going to come our way. So z equals z to the 4 plus 4z squared plus z plus 4. Okay, so z and z here, these can cancel out. So that's then going to leave us with 0 equals z to the 4 plus 4z squared plus 4. Okay, how are we going to solve that? So luckily we've got to the 4 and squared and a constant. So let's have a look at z to the 4 plus 4. So z to the 4 plus 4. Now I know if I do z squared plus 2 and square that, I will get a z to the 4 plus 4 out of that plus another term. So what we'll get out of that, z to the 4 plus 4, 2z squared and a 2z squared twice, that'll give me 4z squared. So there's our bit of luck. We've got z squared plus 2 twice. So therefore our solution is going to be taken from z squared plus 2. So that's a little bit of luck gone our way there. So I'm going to write that up now as z squared plus 2 all squared. Okay, so now I can just take the square root on both sides. And then I'm still going to be left with 0 equals, and now this and this will disappear, and I've got z squared plus 2. Now we know we can solve this one. So now we're going to get z squared equals minus 2. So just take the square root of the minus 2. So z equals, so square root of minus 2. So that's going to leave me with plus or minus I root 2. So minus 1 is, if I take the square root of minus 1, that's going to give me my I, and then the square root of 2. And of course we have the plus or minus values. Okay, so that got us out of a tricky situation there. So plus or minus I root 2. So that's all well and good. Now we need to find the characteristics of these functions. The characteristics of these fixed points, that's got to be found by taking the derivative. So what we're looking for is the absolute value of f prime of z. That's the bit we're interested in for finding the characteristics. So let's take the derivative of this one. So f of z equals z over 3 minus 2. So our f prime of z, derivative of that, well, it's a third of z minus 2. That'll disappear and we'll just be left with the third. So our absolute value of f prime of z, that's just going to leave us with 1/3. Okay, so let's put our absolute values in here, and then I'm going to run through them all at the end. Now what about this one? So f of z equals z squared minus 4. Take the derivative of that, we're going to left with 2z. Okay, now the absolute value of that is still the absolute value of 2z. Okay, so let's just write that in there. So f prime of z equals 2z. Now this one here, z squared plus 4, take the derivative of that, we're going to be left with the same equation there, 2z. So I'm not going to bother with that, we'll just use that for that one. This one here, a little bit more work. So f of z equals z to the 4 plus 4z squared plus z plus 4. So let's go straight into the derivative of that. That's a pretty straightforward derivative to take. We're going to have 4z cubed plus 8z plus 1. So that's our derivative of that one. So f prime of z equals 4z cubed plus 8z plus 1. Okay, let's work out the characteristics of each of the points. Okay, let's take this first one. So our fixed point is minus 3. So let's have a look at our derivative of minus 3. So wherever that is plugged in, minus 3, we'll still get 1/3. So for any value, it's going to be 1/3. There is no z in the derivative anyway. So therefore, the characteristic of this one is our, let's just write the characteristics up here. So f prime of z is less than 1. So therefore, this one here is an attracting or a stable stable fixed point. So this one therefore is attracting slash stable. So we call that one there, plug that one in for that value there. Okay, what about this one here? Okay, let's have a look at this one. So we've got our f of z equals z squared minus 4, and we've got our f prime of z. That's what we're interested in. That one is 2z. So now we're plugging 2z. For 2z, we plug in our values of our fixed point. So for z equals 1 plus square root of 17 over 2. Plug that in there. So this one, our derivative, let's see what we get for that one. So 1 plus square root of 17 over 2. So multiply that by 2. So therefore we're going to get 1 plus square root of 17. So 1 plus square root of 17 is going to be approximately just over 5. So therefore this is greater than 1. So that's going to have different characteristics than this one here. So let's write the rule up for this one. So if our absolute value of our derivative is greater than 1, then our fixed point is then repelling or unstable. So that takes care of that one. Now we've got another value in here where z equals 1 minus square root of 17 over 2. Now if we look at our value of our derivative, let's just be careful how we plug that in. We need to multiply this by 2. So we want the absolute value of square root of 17, 1 minus square root of 17. Square root of 17 just over 4. So 1 minus something just over 4, that's going to give us around about negative 3. Negative 3, take the absolute value, it's going to be greater than 1. So again, this is greater than 1. So therefore, both of these fixed points are repelling and unstable. So that would take care of that function there. Okay, let's have a look at the next function. So again, our f of z this time is z squared plus 4, and our derivative was 2z. Obviously the absolute value. Now let's just check these absolute values. So for z equals 1 plus square root of 15, and then multiply by I over 2. Now just because we've got an I in there, we could just plug in a 1 when taking the absolute value. So let's just have a look at that. So we got 2 times 1 plus I root 15 over 2. So just take the absolute value of that. We can now cancel out our 2's, and then we've got 1 plus square root of 15. So that I, we can just plug in a 1 for that one in terms of absolute value. So 1 plus square root of 15, that's going to be just less than 4. So 1 plus something just less than 4, that's going to be 1 plus 3 and a bit. So that's 1 plus 3 and a bit is 4 and a bit. So this one is greater than 1. So that would also link the positive value to being repelling or unstable. Let's try the negative value. So the z equals 1 minus I root 15 over 2. Let's try for 2z. So 2 times 1 minus I root 15 over 2. That would then yield us to square root of 15 is just less than 4, so it's 3 and a bit. 1 minus 3 and a bit, that's going to give us minus 2 and a bit. So that's still going to be greater than 1. So hence these 2 points are still going to be repelling and unstable, both of them. So they will link to this box. Okay, let's check this last one out. Okay, so now we've got f of z equals z to the 4 plus 4z squared plus z plus 4, and our derivative 4z cubed, and then plus 8z plus 1. And our 2 values are plus or minus I root 2. So let's I root 2. Let's plug that in there. So if we've got 4 times I root 2 to the power of 3 plus 8 times I root 2 plus 1, these are all going to be positive values in terms of the absolute values. So that's always going to be positive, that's always going to be positive, that's always going to be positive. So z equals plus I root 2, that's going to be greater than 1. So that's that one. Now what about the negative value? Z equals minus I root 2. So now we're going to have 4 times negative I root 2 cubed plus 8 times negative I root 2 plus 1. And then take the absolute value. So this is going to yield a negative number. This is going to yield a positive number. So let's see what, this is also going to yield a negative number. So let's just have a quick calculation here. So we're going to have 4 times root 2 is 2 to the power of half. So that's 2 to the power of 3 over 2. Plus 8. So again, we've got 2 to the power of a half times 8. So just put these in brackets and then plus 1. So need to take the negative sign out and change the signs here. So this one here will be a negative. As this one is cubed, when you cube a minus sign, you still get a minus sign. So this one here is also going to be a negative. So we've got a negative 4 and some more, a negative 8 and some more, and add 1. So this absolute value is also going to be greater than 1. So both of these points here are going to be repelling and unstable. Okay,